Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about resolution of vectors. Okay, resolution of vector is the process of splitting the vector into two or more vectors. More vectors. These splitted vectors are called component of vector. Okay. So this resolution of vector is just an opposition of addition of a vector. How it is to becomes we will see now. You see this. This is a B vector and this is a vector. Okay. I am going to add these two vectors. So based on the triangular law of vector addition, two vectors can be considered as the adjacent side of a triangle taken in the same order. So I am taken the A and B are the adjacent side of a triangle in the same order, tail to head, tail to head. Then the resultant is the third side taken in the opposite order. So I can write this A vector plus B vector is R vector. Okay. So if I got R vector alone, the same. So I can split this R vector as one is A vector and another is B vector. Okay, this is A vector and this is B vector. So now you can write that R vector is equal to A plus B. Okay, so this R vector is split into A vector and B vector. This splitted vector is called as component of R vector. Okay, I will show you an example that will make you to clear very much. Okay, then now you see. How you are walking on a ground? How you are walking on a ground? Anybody noticed? Okay, so if this is a ground, okay, then if your leg is exerting up and down, if your leg is exerting up and down like this, you cannot move. So if you want to move in the forward direction, you have to exert a force, make it like a slope, like this. So your back leg has to exert a force in this direction, that is the applied force. Applied force is acting in this direction. Due to this force, you are moving in the forward direction. Okay. So what are the forces are acting on this object? There is an applied force is acting in this and downward mg is there. Okay. So this surface will exert an opposite reaction. Okay. Opposite, there is a reaction. Okay. This reaction make it to move forward. That means I can say that some part of this reaction is used for balancing the mg and some part of this reaction is used for forward motion. In vector form, we can say that one component of this R vector is used to balance this mg and one component is make you to move in the forward. That means I can split this reaction into two. Okay, like this. One is along horizontal, another is along the vertical. This is the horizontal component. This is the vertical component. Okay, so now you see this. The vertical component balance the mg and the horizontal component make you to move in the forward direction. So this is the way you are moving in the forward direction. So from this we can say that any vector can be possible to split into two vectors. Okay. So if you need to split the vector in the xy axis, what you will do? So look at like this. If this is a vector, this is a point. Okay. This is an A vector. If you need to split this vector in vector along the x and y axis, you have to draw two perpendicular axes. Two perpendicular axes x and y. Okay. And draw a perpendicular from this point. Okay. Clear? So this is O and this is Q. So this is one vector and this is the other vector. Based on the parallelogram law of vector addition, I can complete here. This side is equal to OQ and this side, that is the PQ side, is equal to OR. Okay, so this is one vector and this is the other vector. Okay, so based on the parallelogram law of vector addition, I can say that A vector is equal to this vector, that is OQ plus OR. OQ vector plus OR vector. What about OQ? OQ is a horizontal component and is acting along the x-axis. So I can replace this OQ by AXI. Okay, AX is the magnitude of OQ and I is the direction. Okay, I is the direction. So we can say that AX is the horizontal or X component. Horizontal or X component of vector A. Horizontal or X component of vector A. Okay. Then similar way, what about OR vector? OR vector is a vertical component and acting along the y direction. So I can say that the OR vector is equal to AYJ. This J shows the direction and AY is a magnitude. So this we can write it as AYJ. Clear? Okay. So what about AY? AY is the vertical. AY is the vertical component or X component. Sorry, it is acting along the y axis, so it is y component. Y component of vector A. Clear? Okay. This is the thing. So from this, what I can write? The A vector is equal to AXI plus AYJ. This I and J are the unit vectors acting along the X and Y. Okay, clear? Now we will see. If this A vector is making some angle with x-axis, that means you see like this. Okay, like this. This is the x-axis and this is the y-axis. This is the A vector. This is the point P. This is the A vector. This A vector is making an angle theta. So I am going to draw a perpendicular from here. So this point is Q and this is O and this I am taken as R. Okay. So this is the horizontal component and this is the vertical component. Okay. Clear? So from the triangle OPQ, the sine theta is equal to this side, that is opposite side, that is PQ divided by this side. What is this side? That is magnitude of the A vector. So PQ is equal to A sine theta. What about PQ? PQ is this side. Based on the parallelogram law of vector addition, that is equal to OR. Okay, so that is OR is equal to PQ is equal to A sine theta. That is the magnitude of OR. What is the magnitude of OR? We got it as the magnitude of OR is AY. So AY is equal to A sine theta. Okay, clear? Then what about cos theta? Cos theta is equal to adjacent side, that is OQ divided by hypotenuse, that is the magnitude of A vector. Okay, then OQ is equal to what you will get? A cos theta. Okay, then so what about OQ? OQ is the which component? That is the horizontal component magnitude. So AX is equal to A cos theta. Okay, then now we will get one more, that is A vector is equal to, this is the thing, from this AX is equal to A cos theta I plus AY is equal to A sin theta j. Okay, clear? Okay, this is the horizontal component, that is A cos theta. Okay, the component nearby theta is cos theta. Okay, this is A sin theta. Okay, clear? This is the sin theta component. Okay, then what about the magnitude of the vector? Now we will see the magnitude of the vector. Okay, so what is A vector? A vector is equal to AXI plus AYJ. Okay, AXI plus AYJ. So from the parallelogram law of vector addition, the magnitude of A vector is equal to square root of AX square plus AY square plus 2 into AX AY cos of angle between AX and AY. You see this X and Y, the angle is perpendicular, so the angle between them is 90. So this entire term is 0. So modulus of A vector is equal to square root of AX square plus AY square. This is the magnitude. Okay, so if I take an example, that is, if I take an example, if A vector is equal to 2I plus 3j, what about its magnitude? You can see that square root of this, that is AX amount is 2 square, that is 4 plus 9, that is how much you get? Square root of 13. Clear? Then what about the angle? This is the theta. What about this angle? So from this triangle, the triangle OPQ, tan theta is equal to how much you get? Or tan theta equal to opposite side, that is PQ divided by what is that? That is adjacent side, that is OQ. PQ is equal to OR, that is, we can say that AY divided by AX, that is tan theta. So theta is equal to tan inverse of AY divided by AX. This is the direction. So A vector make an angle theta with the X.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like and share.